In this video, we've compiled the top 20 OOP interview questions and answers. From basic concepts to more complex topics, this comprehensive guide will help you prepare and feel more confident during your interview. 1. What are the four main principles of OOP? Object-oriented programming, OOP, is a programming paradigm that relies on the concept of objects. These objects are instances of classes, which can hold both variables, attributes, and functions, methods. The four main principles of OOP are: encapsulation. This principle is about binding the data and the methods that manipulate this data within one unit, i.e., class. It also means to hide the data from outside worlds so that it can't be directly accessed. Abstraction. This principle is about only showing the necessary details to the clients of the object. It hides the internal implementation of the objects and only reveals operations relevant for the other objects. Inheritance. This principle allows one class to inherit properties and methods from another class. It promotes code reusability and hierarchical classification. Polymorphism. This principle allows one interface to be used for a general class of actions. It provides a single interface to different types of data. 2. Explain the concept of encapsulation in OOP. Encapsulation, a fundamental concept in object-oriented programming, OOP, is the process of wrapping code and data together into a single unit, such as a class in Java. It is a protective shield that stops external code from accessing the internal workings of an object. By using encapsulation, you can hide the values or state of a structured data object within a class, preventing unauthorized parties direct access to them. It enhances data security as the users will have no idea about the inner implementation of the class. It is only accessible through the methods of their current class. This mechanism of hiding details and showing only the necessary things to the user is what encapsulation is all about. It also improves maintainability and flexibility, and makes the system easy to understand and handle. Encapsulation, as one of the core principles of OOP, is a technique used to protect the data from outside interference and misuse. It involves bundling the data, and the methods that operate on that data, into a single unit known as a class. This process allows us to hide the class's internal state and only permit access through methods. By doing so, we can prevent the object's internal state from being changed arbitrarily and ensure that it stays consistent throughout the life of the object. This also allows us to have more control over how the object is manipulated, making the code more predictable and easier to debug. In essence, encapsulation aids in achieving data security and integrity by preventing unauthorized access to the class's internal workings. It also promotes code modularity and simplifies the code structure, making it easier to read and maintain. 3. What is abstraction in OOP? Abstraction is a vital concept in object-oriented programming, OOP. It involves hiding the complex details of a system and showing only the essential features to the user. This way, the user interacts with only what's necessary, making the system simpler and more efficient to use. It's much like a car. You don't need to understand all the mechanical workings under the hood to be able to drive it. You only need to know how to use the steering wheel, pedals, and a few other controls. The same idea applies to OOP with abstraction. We can hide complex processes and expose only what's needed for the system to function as required. 4. Define inheritance and its benefits. Inheritance is a fundamental principle of object-oriented programming that allows one class to inherit features, methods, or properties of another class. The class whose properties are being inherited is known as the parent class or superclass, while the class that inherits these properties is known as the child class or subclass. It promotes code reusability as programmers can create a new class, add extra features, and use the existing class. It helps in making the code clean and readable. It also provides an as-a relationship, which is primarily used for code reusability. To delve deeper into this concept, let's consider an example. If we have a parent class called animal, with features like eat and sleep, we can create a child class, dog, that inherits these features from the animal class. Consequently, we don't have to define these features in the dog class again, thus reducing redundancy and enhancing code readability. This is the primary benefit of inheritance. Other advantages include the ability to represent real-world relationships effectively, making it easier to create and maintain applications. 5. What is polymorphism and how is it implemented? Polymorphism is a fundamental principle of object-oriented programming, OOP, that allows objects of different types to be treated as objects of a common. This enables us to use a single interface to represent different types of entities, thus increasing the flexibility and interactivity of the programs. There are two types of polymorphism in OOP: compile time polymorphism, or static polymorphism, and runtime polymorphism, or dynamic polymorphism. Compile time polymorphism is achieved through method overloading and operator overloading. It is determined during the compile time. On the other hand, runtime polymorphism is implemented through method overriding and interfaces. It is decided during the runtime. Polymorphism allows objects to decide the correct method to call at the program's runtime, based on the type of the object. 6. What is the difference between an abstract class and an interface? An abstract class is a class that contains both abstract, unimplemented, and non-abstract, implemented, methods. It serves as a blueprint for other classes and cannot be instantiated. On the other hand, an interface is a completely abstract class that contains only abstract methods. As such, all methods in an interface are implicitly public and abstract. While a class can inherit from only one abstract class, it can implement multiple interfaces, providing more flexibility. In terms of access modifiers, an abstract class can have public, protected, and private methods, whereas interface methods are always public. In simple terms, an abstract class is a half-defined class which lays out the foundation for other classes, whereas an interface is like a contract that dictates what methods a class should have. The key difference lies in their usage. When you want to provide common functionality to related classes, use an abstract class, but when you want to define a contract for what a class can do without defining how, use an interface. 7. Explain the concept of method overloading. Method overloading is a concept in object-oriented programming, OOP, that allows a class to have more than one method with the same name, but with different parameters. Its main purpose is to increase the readability of the program. It provides flexibility and allows developers to write code that is easier to read and understand. Method overloading can occur with different numbers of parameters, different types of parameters, or even a different order of parameters. However, changing the return type of a method does not constitute overloading. For example, consider a class that can use addition in various ways. One method might add 2 integers, while another might add 3. Another method might add 2 doubles. All these methods would have the same name, addition, for instance, but different parameters. It's important to note that Java, C++, and C support method overloading, but languages like Python or PHP do not. Method overloading allows programmers to write clean and intuitive code, making the program more efficient and user-friendly. 8. What is method overriding? Method overriding is a feature in object-oriented programming, OOP, that allows a subclass or child class to provide a specific implementation of a method that is already provided by its parent class. It is used when a class wants to inherit from the parent class but needs to change the behavior of a particular method. When invoked, the method in the child class will be executed instead of the method in the parent class. This concept is crucial in achieving runtime polymorphism. In method overriding, the method in the subclass must have the same name, return type, and parameters as the one in the parent class. The keyword super can be used to call the overridden method from the parent class if needed. A fundamental aspect in OOP, method overriding plays a vital role in providing flexibility and increasing reusability of code. When a class inherits from another class, it often requires a different behavior for a certain method. By overriding the method, the subclass can provide a specific implementation without altering the method in the superclass. Consider a shape class with a method to calculate area. A square subclass inheriting from the shape class will need to override the area method to provide the correct calculation for a square. Similarly, a circle subclass will override the same method to calculate area of a circle. This real-life example illustrates the importance of method overriding in OOP. Notably, method overriding allows for runtime polymorphism where the object determines which method to invoke at runtime. It enhances code readability and organization by keeping the related methods in respective classes. 9. What is the purpose of the this keyword? The this keyword in object-oriented programming, OOP, primarily serves as a reference variable. It refers to the current object, i.e., it points to the object of the current class. This comes into use when a field, class variable, is shadowed by a method or constructor parameter. For instance, if a class has a variable x and a method within the class has a parameter also named x, the this keyword will be used to distinguish between the two. This x refers to the class variable, while x refers to the method parameter. Additionally, this can be used to invoke or initiate the current class's constructor and can also be passed as a parameter to other methods. However, it cannot be used in static contexts as it is a reference to the current object, and static methods do not have access to any instance of the class. 10. Explain the concept of constructor overloading. Constructor overloading in object-oriented programming, OOP, refers to the ability of a class to have multiple constructors with the same name but with different parameters. It is a technique of having two or more constructors in a single class, each performing a different task. The correct constructor is chosen at the time of object creation based on the arguments passed. This concept provides flexibility and improves code readability by allowing programmers to initialize objects in different ways based on the context. For example, consider a rectangle class. It can have multiple constructors where one initializes the length and breadth using two parameters, whereas another one initializes only the length assuming it to be a square. Hence, with constructor overloading, more than one constructor is available in the class. 11. What is the difference between composition and inheritance? Composition and inheritance are both object-oriented programming concepts. Inheritance is a type of relationship because it allows one class to inherit the properties and methods of another class. In contrast, composition has a type of relationship, as it allows one class to contain another class. The main difference between the two is that inheritance creates a relationship between two classes through the parent-child relationship, while composition links classes through their objects. Inheritance promotes code reusability, but it can lead to a high degree of coupling. On the other hand, composition promotes code flexibility and reduces the degree of coupling. Inheritance allows for code reusability and representation of real-world relationships. However, it can also lead to problems with high coupling and fragility. For example, changes in the parent class can affect the child classes, leading to a lack of flexibility. On the contrary, composition is more flexible as it allows a class to change its behavior at runtime by setting and changing its members. It reduces the dependencies between classes, leading to a lower degree of coupling. This flexibility and loose coupling make it a more preferred method in many scenarios. 12. What is the purpose of the super keyword? The super keyword in object-oriented programming, OOP, plays a significant role, especially in the context of inheritance. It acts as a reference variable that is used to refer to the immediate parent class object. There are two main uses of the super keyword. First, it can be used to call the parent class's method when it has been overridden by the child class. This allows for code reusability and a cleaner, more efficient code structure. Second, it can be used to call the parent class's constructor, which is beneficial in the scenario where a constructor in the child class wants to call the constructor of the parent class. It is important to note that the super keyword must be the first statement in each constructor. In essence, the super keyword fosters the principles of inheritance in OOP by enabling a subclass to leverage and manipulate elements from its superclass, promoting code efficiency and reusability. 13. Explain the concept of method hiding. Method hiding is a crucial aspect of object-oriented programming, OOP. It occurs when a child class declares a static method with the same name as a static method in the parent class. The method in the child class hides the one in the parent class, hence the term method hiding. This is different from method overriding, where an instance method in the child class overrides the instance method in the parent class. However, in the case of method hiding, it is the static methods that are involved. The primary reason to use method hiding is to prevent access to the method from outside the class, ensuring that the method is not altered or called incorrectly. This can help improve the stability of the code and reduce the likelihood of bugs or errors. While it's useful, method hiding should be used judiciously. Overuse can make the code more difficult to read and maintain, so it's best to use only when necessary. 14. What is the difference between early binding and late binding? In object-oriented programming, early binding and late binding refer to when an object or method is bound to its definition. Early binding, also known as static binding, happens at compile time. The compiler knows at the time of compilation which method or variable will be invoked or used. Therefore, this binding provides better performance as the type of object is known in advance. On the other hand, late binding, also known as dynamic binding, happens at runtime. The compiler does not know in advance the method to call or the variable to use. This binding is more flexible as the method is decided during runtime based on the type of object. However, it could lead to potential runtime errors if not handled properly. 15. What is the purpose of the final keyword in OOP? The final keyword in object-oriented programming, OOP, serves a specific function. It restricts the user from changing the value or behavior of an entity. When final is used with a variable, the variable becomes constant, meaning its value cannot be altered after being assigned. When final is used with a method, the method cannot be overridden by any subclass. This ensures that the method's functionality remains the same for all subclasses. Finally, when final is used with a class, It prevents other classes from inheriting from it. This is useful when you want to make sure your class's behavior and characteristics are not modified or extended by other classes. One good example of a final class is the string class in Java. As it is marked as final, no class can extend it, and it ensures that every string is immutable. 16. What is the difference between shallow copy and deep copy? A shallow copy creates a new object, but fills it with references to the original objects. This means that changes to the original object will affect the copied object, as they are still pointing to the same data. A deep copy, on the other hand, creates a new object and populates it with copies of the data found in the original object. Thus, changes to the original object will not affect the copied object as they do not share the same data. Deep copy is more process-intensive than shallow copy as it involves creating duplicates of the original data. 17. Describe the concept of mixins in OOP. Mixins are a concept used in object-oriented programming, OOP, to create classes that can provide a certain functionality to other classes, without requiring them to be their parent class. They are intended to add or augment the behavior of a class in a specific way. This is achieved by allowing a class to inherit from multiple parent classes, which could contain many properties and methods. Using mixins, we can essentially create small, reusable pieces of code that can be incorporated into other classes as needed. Mixins can be viewed as a form of composition, where each mixin is designed to implement a specific behavior. This design pattern promotes code reusability and modular programming, avoiding the need for complex inheritance hierarchies. 18. What is the difference between cohesion and coupling? Cohesion refers to how closely all the routines in a class or module are working towards a common goal. It is the degree to which elements of a module belong together. Ideally, a well-cohesive module should perform a single task, meaning that the module should have a single, well-defined purpose. On the other hand, coupling refers to the degree or level at which one module depends on the other modules. In other words, it is the strength of the relationship between modules. Low coupling is often a sign of a well-structured system as it indicates that each module is independent and can function without the others. The goal in designing software is to increase cohesion and decrease coupling. High cohesion means that a system is well organized, and low coupling means that it has fewer dependencies, which in turn makes the system more flexible, adaptable, and easier to maintain and understand. 19. Explain the concept of the open-closed principle. The open-closed principle, one of the 5 principles of SOLID, is a core concept in object-oriented programming. This principle states that software entities such as classes, modules, or functions should be open for extension but closed for modification. This means that an existing code should not be altered when adding new functionalities or behavior. Instead, we should be able to extend the code, thus allowing the addition of new features without affecting the existing ones. This principle aids in reducing the risk of issues or bugs when introducing new functionalities and makes the application easier to maintain and manage. The open-closed principle encourages developers to write code that is more reusable and less prone to errors. By adhering to this principle, we can achieve a more robust, flexible, and maintainable codebase. 20. What are anonymous classes and when would you use them? Anonymous classes are unnamed classes, defined in the form of an expression, primarily used for creating simple, one-time objects. They are most commonly used in situations where a class definition is required only once. In such cases, it would be unnecessary to formally define a class with a specific name. For instance, when dealing with event handling in graphical user interface programming, anonymous classes are often used to encapsulate event responses in a concise, straightforward manner. Anonymous classes are also frequently utilized when working with threads or runnable objects, and they can be a convenient tool in contexts where a full class definition would be excessive or unnecessarily complicated. The primary advantage of anonymous classes is their ability to allow for cleaner and more readable code, particularly in scenarios that call for the creation of simple, single-use objects. If you found this video helpful, please hit the like button and consider subscribing to our channel for more valuable content. Your support helps us continue to provide high-quality resources.